So in example B, we have the points for A and A prime, which give us -4, 1, the points for B and B prime, which give us 0, -1, and the points for C and C prime, which give us 4 and -3. And when we connect that line, that gives us our line of reflection. So pause here to do reflection question number 11, and then your turn numbers 12 and 13, and come back when you're done. Number 11, one way to do it is to use a ruler to check that line L bisects line AA prime, and you can use a protractor to check to see if it's perpendicular. And these are numbers 12 and 13. So we have the midpoints for line AA prime, BB prime, and CC prime, and that gives us these 3 points. So when we draw line L, the reflection line, we end up with an exactly diagonal reflection line. With 13, because the points cross each other, we have A to A prime, B to B prime, C to C prime, which gives us this line of reflection here. Please let me know if you have any questions with this. We have one more section to go. And next on Explain 4, we have applying reflections. And this is all about word problems and actually taking what we know and applying it to real life. So in this scenario, we're at a mini golf course and we're trying to get from the tee to the hole, and we can't go straight in because there's a corner in the way. We have to figure out where this point is so that we can hit that point and it will go exactly into the hole. So we're going to put this whole thing on a coordinate plane, and they've done that for you in the example. Now, one thing I need you to understand about this, and you might have learned this in science in a physics class, is that the angle of incidence equals the angle of reflection. So if, and we're going to use logic to work our way through this. So this is our straight line wall, and this is our T, and we're trying to hit it into the hole. The angle that we hit this wall with, angle 1, equals the angle that it will reflect off of, angle 2. The angle of incidence equals the angle of reflection. If we reflect this angle, point T and point H, over this straight line, we will end up with H1 way over here. We know that this angle is the same as this angle. When we reflect this, this angle is the same as this angle. Because when we reflect it, those angles have to be the same. When you fold that in half, those are gonna match up. So when the ball goes from T to the wall in a straight line, if that wall wasn't here, it would continue in a straight line off in this direction. Now we know from algebra last year, when we have two lines that intersect like this, that this angle equals this angle, and this angle equals this angle. So we have an X here made out of this line and this line. So we know that angle 3 equals angle 1. Because of the law of reflection, we also know that angle 1 equals angle 2 because the angle of incidence equals the angle of reflection. And that makes sense because these are reflections of each other. Angle 2 and angle 3 equal each other. So all of the logic in the world points to that being correct. Now, I know that I need to find this point on the coordinate plane. I need to know exactly where I'm aiming this ball to hit the wall. When we look at this on a coordinate plane, it's a little bit easier to see. We're looking for the point exactly where we need to aim this ball so when it hits the wall, it goes here. We know that this is going to continue out in this direction if the wall didn't exist. We know that this angle equals this angle. And we know that this line is a reflection of this line and vice versa. If we were to reflect point H over the wall line, we would be, that's a straight 1, 2, 3, 1, 2, 3. That's a straight reflection. It's going to go straight over. So if we look here, H is 1 unit from the wall. And so we're going to go exactly horizontally 1 unit from the wall. So this is H prime. Once you've got point H prime plotted, then you draw the line between T and H prime, and you see where it crosses the wall line. And so this point is approximately 3, 4, 5, 6 and 3.5. And that's the point to aim for. So pause here and give 15 a try and see if you can come up with similar results. Come back when you're done. So with 15, we're going to reflect point C over the side rail line that is our reflection line. So we went in 1, 2, we're going to come out 1, 2. This is C prime. Then we're going to draw line AC, and we're going to draw it straight because we want to go from A to C, and we want this angle to be the same as this angle. And where line AC prime crosses the side rail is right here at point -1, -1, and you're going to aim there. So try to do questions 16, 17, and 18, and pause here, come back when you're done. Number 16, any point on the line of reflection has itself as an image. So if it's on the line, it is its own image. It's part of the definition. Number 17, you can fold the paper so the image lies on top of the figure. And then the fold line is the line of reflection. And number 18, for each vertex, x and y equals x negative y. The x stays the same and the y becomes its opposite, the negative. Your homework for this section starts on my page 81. You're going to do numbers 5 to 28 all. And let me know if you have any questions. I'll see you next time.